Yes, Darshini, Bharat, Dashrath, listen, all of you, the last year you did the ACT activity program, right?
Yeah, sir.
All of you did the ACT activity programs. Say, for example, Dandeli trip, Dandeli, activities, maybe just 20, 20 hours, okay? That you make it like that. And what are the activities you did there? And just to mention in the Google Sheet, right? And then another activity you did in the what is that called?
Horgin better.
ಹೊರಗಿನ ಬೆಟ್ಟ ಅದನ್ನು ಕೂಡ ನೀವು ಅದ್ರಲ್ಲಿ ಮೆನ್ಷನ್ ಮಾಡಿಬಿಡಿ ಅಂತಂದ್ರೆ ಇಲ್ಲ. ಸೊ ಅದು 20 hours. ನಿನ್ನೆ ನಾನು ಯಾರ ಜೊತೆ ಮಾತಾಡಿದೆ? ಯಾರೋ ನಾನು ಕೇಳಿದ್ರೆ ನಿನ್ನೆ.
ಸರ್ ನನ್ನ ಜೊತೆ ದರ್ಶಿನಿ.
ದರ್ಶಿನಿ ಹೇಳಿದಿರಮ್ಮ, ಎಲ್ಲರಿಗೂ ಹೇಳಿದಿರಾ?
ಫಿಲ್ ಮಾಡಿದ್ದಾರೆ ಸರ್.
Okay, good, very good. That is a documentation purpose we required because you did a very hard work and should not go in the waste. Should get that. You update it, all of you update please that, okay? And that is a thing. And what about that MOOC which I shared for the basic survey? Hope you all did that, and you uploaded in the Google Classrooms. I hope you uploaded.
Yes, sir.
Anybody is the not yet done any? Anybody is not yet done? Everybody is done. Around 45, 46 students you are there, right? So hope you all of you done that. Right. Right then. Let's go with continuation of the the first second hour class. So in the second hour class, we derived some of the equations and also from some of the that's what we call there are some of the problems we derived. Okay, and the same thing I'm going to give you the notes and you can go through the clearly if it is not visible properly. Of course, it's visible, but some pages are not that much of clear. Okay. That the keynote I'm going to give you that, okay? And problems and the equations which we discussed in the morning, it's errors in trigonometric and logarithmic values and how we are going to process in a mathematical way, and also the related to that we solve some problems that's all with the quantities related to that, and that's a maximum error and probable error. What is that? So maximum limit, minimum limit, and maximum probable error. Those forms, the problems we discussed in the last class. So here in this class, we are going to discuss about the that's called measurement of horizontal distance. So how we are going to measure the horizontal distance and with the plane land and as well as in the slope areas, especially in the slope areas. Plane land, it's not a problem. Slope, where there is a slope, there is an issues, the angles, okay, that we need to will solve some problems. Okay, so there are different types of it's called the measuring the horizontal distance. One is a direct method, that's called pacing, passometer, pedometer, that we discussed in the theory part. Okay, and also the indirect methods. Yeah, that is these are all the direct methods. Indirect methods, the distance or obtained by calculation by using the tachymeter and triangulations. That's called the indirect method. Direct method is in the sense field itself only you will come to know that, right? So in the again it's in the EDM, that is called electronic distance measurement methods. That is another methods. So here is we discussed the different types of steps, steel and all those things. And in survey lines, types of survey lines, this is the most important. Most of the times it appears in the exams. That's called your direct ranging and indirect rangings. Okay, what do you mean by the direct ranging? Okay, here there are direct ranging is done when the two ends of the survey line which are intervisible. which are intervisibles. That means there is no obstacles in between the 2 points. There is no bushes, or there is no, the topography is very flat. I mean, it's very flat land. It's not, there is no undulating topography. So that in the such a cases, the intervisible between the 2 points, two stations, A to B or B to C, whatever the things, those things can be intervisible. In such a cases, ranging can either be done through the eye or through the some optical instruments. Okay, that's called, theodolite, or it may be, you can use it your what you call total sessions. So, and ranging by eye also you can do that. That is a very simple one, but you need to do some the alignment for your from A to A and B points, the 2 points at the end of the survey line. Okay, one ranging rod it should be erected at the point of B, and where with the supervisor stands, and another ranging rod at point A. Point A and point B, two ranging rods should be fixed there. Then you will get the proper alignment there. Okay. All right. Let me share the the notes there, so that you can so easily. Yeah. 2 points, right? Yeah. Right. Okay. So here, as you see that these are two types of the survey types of survey lines. One is direct ranging and indirect ranging. Direct ranging by eye you can do it easily, but you need to do some alignment. That's with erecting the ranging rod on either side of the end, A and B stations. Okay, then you make it proper alignment with the assisting there. Okay, and ranging from point A to B point. Okay, if you require, you can establish the intermediate points. Okay, these are all some procedures. I mean, you can explain with your assistant, those who are going to handle the or holding this the stations locations. Just you can give the left side or right side, or it can move for another 2 feet or 3 feet. Okay, how you need to hold the the ranging rod and all those things. You need to give the signals by the surveyor to the your assistants or to your partner, those who are going to handle the these ranging rods. Okay, so another thing is ranging by line hanger. The line ranger consists of either two plane mirrors of two right angles. Okay, these things that's called a prism placed at one above the other, as shown in the figures. Right, that's figured in the next pages. Okay, the diagonal of 2 points. Sorry, the two prisms are what you call this reflect. It should be a reflect for that. The two prisms are silvered as so as to reflect on the incidental phase. Okay, and you need to handle with the hook with the provided at the bottom of to hold the instruments in hand, and the transfer at the point on B and ground with help of the plumb knob. So here is the plumb knob is working very importantly. Okay, and the next part is that with the ranging point, and the two ranging rods are fixed at point A and B. Okay, and you can it can be, and the survivor who is holding the point B ranges very near to that AB by eye adjustment. So if the two points A and B is all intervisible, if it is intervisible, there is no issues. That's very clear. If there is any undulating topography, if there is any bushes, then we have to establish the intermediate point. That's all. Okay, that's a very simple one. And here is the the prisms, the prisms mirror image we need to set up there. Okay, if you have using the prisms and all. Okay, so next is that reciprocal indirect or reciprocal ranging. The ranging is, uh, actually the, yes, let's jump put it there. Uh, right. So in the ranging, in the reciprocal rangings, the ranging is sorted to when the both ends of the surveyor lines are not visible. That's in the bushes. Okay. So this is a very simple the things which you can easily do it. Yeah, here you can see this. This is an undulating topography here. Okay, point A and point that's a B. Okay, and you cannot see that because of this undulating topography. Okay, how you are going to do? You have to establish the intermediate 2 points. First, you need to whatever the possible of visible range. You cannot fix this M here, the intermediate point, because it's not visible again for you. The point should be visible at the foot of the ranging rods, okay, or staff. Okay, you can fix the first point here and measure this, establish here, and again you can establish the another point N. Then from N to the B point you can establish easily. Okay, this is how you can A and B, right? In between M1 and M2 are the intermediate points, right? This is how there are the indirect methods or hypothetical you can do chaining, or even by what you call this line sloping rounds. There are two methods. One is direct and indirect methods. So direct methods, angle measured by clinometer. Difference. Second method is the difference in level measured by the Pythagoras theorem. Okay, and third one is the hypotential allowances. That's with the trigonometry. That's a very simple one. So here is the the next one is the direct methods. This is a very simple one. How we are going to fix this? So this is a point A and B, and this is a slope round here. Okay, it's a very stepping. Okay, so L1, L2, L3, L4, and L5. So horizontal distance, this is D plus, so horizontal distance is a D, and this is called L1, L2, L3, and Ln. Okay, so here we need to fix the ladder, or sorry, what you call this ranging rods A and B, and measure the distance. Because of slopes, you need to take the angle of inclination of these slopes. Okay, so here is the very simple one, and the follower hold the zero end of the tape with the A point, which is that ladder select any suitable length of L1 and L1 of the tape and measure the forwards. Okay, and the follower direct the leader for ranging, and then the leader pulls the tape with the make it horizontal and traverse the line by plumb box to the fix the point. And L1, once you finish, he has to extend the tape with the L2 range. So the procedure is then you have to repeat for till the point B. Okay, and that will be the total distance or length D is calculated by L1 plus L2, L3, and so on. This is the only method used in irregular slopes where there is a slope is undulating. Look at this here. It's undulating topography. That time we will use that things. So in indirect method, this is a direct methods. You can see it and you can step out it. Okay. So in the indirect methods, let L1 is measured inclined distance between the A and B. Let theta 1, the slope of AB with the horizontal. What is the angle of this? Right? That we have to do it. Theta is the angle of inclination of the slope. Okay. And the horizontal distance D1 is given by L1 cos theta 1. That's equal to D1. This is equal to D1. And also similarly BC. Okay. BC is equal to L2 cos theta 2. So we need a required horizontal distance between any 2 points, that may be A to B, that is equal to summation of L cos theta. So slope of the line can be measured with the help of clinometer. That's an angle. Okay, and here is the so this what you call this page is not visible properly. I can read it. It's clinometer. It consists of line of sights and graduated ring, line of sight, graduated rings, and again we have to use the light, the plumb bob with a long thread suspended at the center of the at the center. For this, when the clinometer is horizontal, this will be the range. When the clinometer is inclined, and here is the plumb knob will be, and here is the D1 and D2. Okay, and this is your A to B is the supposed to measure the length. Okay, right, A to B and B to C. Okay, this is the thing. Okay, and in second method, the difference in elevation measured. Okay, that is also possible. Sometimes in the place of measuring the angle theta, the difference in the level of between the 2 points with the help of leveling instruments. You can use the leveling instrument, and the distance it can be computed. Okay, that's another methods. This one directly there. This is height of that. What is that? What is elevation here? And what is elevation here? If you make it difference, this is the height of that, and distance will you get it here. Okay, horizontal distance, and it's a slope distance. That's all about d is equal to square root of L square plus h square. This is a L square slope distance, and h square is the height of the height difference between these two, right? So in the third method, in this method, the correction is applied to the applied in the field every chain of length, at every point where the slope is changing, huh? And the facilities in the locating or surveying the intermediate points which can be changed with the strength of slopes. So this is a little bit difficulty, because every chain or every the wherever the slope is changes, if you are going to measure the angle, that is a little bit difficult part, right? So all in the final, what we are going to calculate is that in this here in the figure, okay. So here what we are going to do, that the arrow is not in the things, the distance A and A dash. See here you can see this, right? A and A dash, A and A dash. This is how the things here. The horizontal equivalence of BA is equal to the chain of equal to one chain. Okay, and thus BA is equal to 100 seconds length, and this is BA dash is equal to 100 lengths, and solve to A dash, that's equal to 100 seconds theta minus 100 lengths. So this is all you can get it that with the levelings, right? Yeah, here is the, I think it's a little bit blur. Okay, so these are some of the problems which we need to understand, especially for this, right? Okay, the distance between the points measured along the slope is 428 meters. Find the horizontal distance between them. That is how the question see here. In them, that's the first question. In that, if the angle of slope between point is B, what is that? And if the difference in the level is 62 meter. Third is if the slope is 1/4. These are the the questions. The distance between the points measured along the slope is 428 meters. So all we need to do, need to find out the horizontal distance between the between them, if the angle of slope between points B, and if the distance is in a level 62 meter, and if the slope is 1/4. Okay, so here you can see the given data. What are the given data here? So D is equal to 428 meters, and theta is 8. Angle of inclination is that's called your 8 here. Okay, angle slope of this, right? So here is the, horizontal distance, let's say capital D, and here is the, A point, and here is the B point here. Here is a A point, here is a B point, okay? And actually, the slope distance, what they have given here, slope distance 428 from A to B, and the slope distance is a 428 meters. So, right. So then what is shear? If the difference in the level is 62 meters, so point A and point B. So this RL will be the different and this RL will be the different. So if you subtract these two, the difference will be the 62-meter height. So that means from A to B, it will be 62 meters. Okay, you got it. These are the given data. So now let us start with the first questions. If the angle of slope between points is 8 degree, theta is equal to 8 degrees. Okay, so all you need to D is required. So D is equal to L cos theta. Okay, then cos theta D by L when you do the cross multiplications, right? And see here D is equal to 4.28, sorry 428 multiply with the cos theta. Cos theta means cos 80 degree. Okay, first you calculate with the cos 80 degree and multiply with the same answer with the 482. So all the final answer you will get it so 423.83. Okay, this is the distance between the points. If the angle of slope between points 8 degrees. So in the second question, so if the difference in the level is 62-meter height between these two points, if the level is 62 meter, the answer will be the different. If the difference in a level, if it is a 80 meter, the answer will be the different. So if the difference in the level is 62 meter, so d square is equal to L square minus S square. Okay, so where is a H here? This is a H here, height, and this is a L, length of that. So here you can see this, here you can see this. It's a little bit blur. Okay, now it's visible, I think. So d square is equal to L square minus H square. Okay, and d is equal to square root of L square minus H square. D is equal to, then when you convert this, so square root of 428. This is the actual length of slope of the from A to B point. So it's a 428 minus 62 squared. This is a height. L squared minus H squared. This is. So finally you will get 423.48 meters. Okay. See, answer is almost same here. You look at this. We are calculating the distance only. Distance between the points measured along the slope. Okay, that will be almost same. 23 meter 0.48, and here is the 423.83. Whichever method you follow, the answer should be the same. That's what it means here. So here is this. Okay, and now so here next point is that if the slope is 1/4. The slope is 1/4. In that case, you have to use the tan squares. Okay, theta is equal to tan to the power of -1. H by is a d. H, you know the h here. This is a h of this. Okay, you know the d here. You can use any d of this. For that, you need to use the. You need to calculate the d before this, so that you can easily calculate the rest of the things. D is equal to L cos theta. L cos theta. You know the L here. You know the theta values. Okay, that is yeah. No. That's the final one. Okay. So you know the D here. You can apply the distance of 423.83, and that is 1/4 here. The angle of slope is and you will get 14.036. So when you convert into the degree, minutes and seconds, that's called a 14 degree 2 minutes and 10 seconds. So when you apply this d is equal to L cos theta, so you will get 428 cos 14 degree 2 minutes and 10 degrees. Okay, so here is a 14.22 meters, you will get it. So this is the very simple one. First, you need to understand what is the angle. What is the angle, what is the distance, what is the height there. That's all. The rest of the things will be very easily you can handle this. Okay, and the next part is that. So when theta, the angle in a radians, when theta is in degrees, when theta in the 1/4, 1 by nth of the slope. Okay, and what are the the formulas which you need to follow it in the question itself. We are giving the theta in radians or degrees or in the slope. So here is the secant theta is equal to, theta is in radians. If the theta is in radians, secant that is equal to 1 plus theta square by 2, and that's called a dash, that's called 100 by secant minus 1 lengths. Okay, and another formula, this a dash is equal to 100, 1 plus theta square by 2 minus 1. Okay, so here is the same thing. So a dash is equal to 100 square lengths. So as you required, we can use it. Okay, no need to use all in one problems. Okay, right. So this will be the it's called secant theta is equal to 1.5 by the 10,000. It depends, right? So these are all the some of the formulas. The for the when degree, when theta is in degrees, when theta is in radians, when theta is in slopes, right? So here is that another what you call this the problem. Okay, right. So another problem here is that find the hypotential the hypotential alliance for the chain of 20-meter length, for the chain of 20-meter length. Okay, right, and it has a length of 0.2 meters. Okay, if the angle of slope is 10 degree, is that if the ground rises by 4 meters, is if the ground rises by 4 meter in one chain length. So what is that? So here is the angle of slope is 10 degrees. So what they are giving is angle of slope is 10 degrees. Which formula is using? A dash is equal to 1.5 by 100. Theta square lengths. Yeah. Okay. Okay. Here is that 1.5, 100 is that. Theta is what is that? 100. 100 in the sense that's called your theta square. 10 multiplied by 10 is 100 lengths, and you can cut out 1.5 the lengths. Okay. So altogether you will get a dash is equal to 0.3. And the second one is if the ground rises by 4 meter in one chain length. What is that? 4 meter in one chain length. So you have to use this the every 4 meters, right? This is a 4 meters. Yeah, this is a 4 meter height. Okay, it's a one chain every 4 meters. If you rise it, okay, this is a 20 meter, right? Yeah, it's a chain link has 0.2. All right. So here is the that's a 20 meters and convert it, and this is a 4 meters, right? So 1 and 4, so 1 and 5. Okay, right. Cross it. So 1 by n is equal to 4 by 20, and this is 20 by, this is called a 5. Okay, 1 by 5, that's equal to n. That means if the ground rises by 4 meter in one chain, okay, the hypothetical length of the chain of 20-meter length will be a what do you call this 5. So here is the what you call the AA dash. That's a 50 by n squared. That's a link, and 50 by n squared means that's called a your 20 here, 20 meter, right? Is a 20, right? It's a 25 meter. Oh, okay. So n square means n5 is there. That's a 25. Okay. So here it's a dash is equal to 2 links, right? Right. That's the final answer. The a dash is equal to 0.4. 2 multiplied with a 0.2. That's all together will be a dash. That's a 0.4. Right. So same for the methods in next problems in chaining the a line. What is the maximum maximum slopes in degrees and in 1/4 and 1/n which can be ignored if the error from this source is not to exceed in 1 in 1,000. Okay, so all you need to do now here, a dash is equal to 1 by 100, 1 by 1,000 multiplied with 100, that's equal to 0.001. That means so one chain that's equal to 100 links. Generally, the one chain is equal to 100 links will be there. Okay, in degrees, if you say that a dash is equal to that is a 1.5 theta squared by 100. So hope we have here theta squared by 100. Okay, here is the formulas. Okay, all right, 1.5 theta squared by 100. So 0.5 is a 100. What they have given here. So that's got our links, and we're by 1.5. So all we look at it is theta is equal to 2.58 degrees. Okay, so slope in one end, that's a dash is equal to 50 by n squared. 50 by n squared. What is the n value here? Yeah. So you will get, when you do the cross multiplications, okay, n square is equal to 500. So altogether, n is equal to 22.36. Right. Yeah, these are the few problems by using the when the theta is in radians or in degrees or in slopes. Okay, these are the small problems and the simple one, and the next one is the that we discussed before that. That's distance between the points measured along the slope. That's the most important one where you are using most of the exams. They go for this type of methods. Keep eye on this, right? And it's a very simple one. Okay, right, and right, yeah. Yes. Then we are going here now. Yes, this we already discussed there in the last class. That's a theory part. Okay, errors in taping or chaining. Okay, during the chaining, tape or chain. When you are using the tape or chain, so what are the error or mistakes arises? These are all things we discussed there. Anonymous length of chain was what you call chain length, careless of holding or marking, and bad ranging, bad straightening, and also like sag in the chain. Okay, variation in the temperature, variation in the pool, and personal mistakes. These are all the errors in taping or chaining. Okay, and these are all the theory part which we discussed in the last class in the PPT. Okay, I'm not going to much taking that part. So bad weathering and chaining and all those things. Okay, right. So the problems, you need to concentrate a little bit on the problems. These are some of the, the typical, the formulas will be there, which you need to concentrate on that. It's a very simple one, right? Huh? Yes.